And welcome to the Daily Space Weather. Smasho here, coming at you with another fascinating space weather broadcast here from the Smash News Network. Least busted name in news. We've got multiple CMEs here to cover. We're expecting one to strike Earth later today. Yes, late today, possibly early tomorrow. And are any of those CMEs earthly directed? We'll get to it later in the video, so stay tuned for that. We've got quite a lot of sunspots still here in the northern hemisphere, and a bit of growth here in sunspot 3112. So the likelihood of additional flares coming from that rises today. Here's a colorized magnetogram from SDO. Let's blast through some more data here as there's lots to cover. Pyroclastic flows happening at Stromboli, not to be confused with a calzone. Pyroclastic flows coming down Stromboli, engulfing Sierra del Fuoco. Yes. So some major activity happening there at Stromboli. Nishinoshima also erupting here. An uptick at Nishinoshima as it explodes. Flight level 120, it's a 12,000-foot ash plume from Nishinoshima. Explosive eruption continuing also at Sakurajima. Lava bombs being ejected from Sakurajima. Suwanosejima also exploded, produced a flight level 040, it's a 4,000-foot ash plume. We've got Mount Mayon in the Philippines there, having the volcanic risk level raised to level 2. Sulfur dioxide emissions up to 391 tons per day. Also some steam-laden plumes coming out of that. Perhaps an eruption impending there. Katmai. No report there on Katmai, but it's on the list for whatever reason. Popocatépetl exploding in central Mexico, flight level 200. Nevado del Ruiz, no emissions observed in Colombia. Sangay and Revenador both exploding in Ecuador, flight level 200 from Sangay. Flight level 160 from Revenador. It's a 16,000-foot ash plume. 22,000-foot ash plume from Sabancaya as it explodes in Peru. And we're unable to detect Nevados de Chilean. Don't assume it's not erupting and decide to pole vault the caldera. It could be unhelpful. There's the 90-day bar graph of seismicity for planet Earth. And the largest quake of the past 24 occurred in the equatorial Atlantic Ocean. There is the location of that. It was a 6.2 magnitude, and it came in at 1638 yesterday on October 9th. Let's scroll up the list. Besides that, things have been fairly calm here. No major quakes besides that 6.2. Papua New Guinea did have a 5.4. They're north of Australia. Fiji had a 5.5. That is, I believe, the second largest quake of the past 24 hours. And thanks for leaving a comment, Tinman1057. Good morning to you as well. And that is the end of the earthquake coverage. Getting back to space, here's the last 24. In our house favorite wavelength, 171 angstroms from SDO. As we bring you daily the most detailed imagery you'll find anywhere of the sun and the most comprehensive space weather in the known universe. So we've seen an increase in the radio flux here. It's now up to 161 solar flux units. If you're wondering what a solar flux unit is, it's 10,000 joules of radio flux density. And there is the, check it out, this uptick here in the past about 3 months. Just a straight up uptick there. Higher highs and higher lows as solar cycle 25 continues to ramp up. There's the space weather enthusiast dashboard here, and NOAA expecting some geomagnetic storm and unrest conditions because of, quote, transient influence. We are expecting some geomagnetic storm or unrest conditions late today possibly through midday tomorrow. So that's about the time that we would expect it to be happening, sometime in these time frames. We're expecting a KP 4 to 6 for a brief period there from a CME. I don't know why nobody else saw it, but hey, what can you say? Let's take a look at Earth's geospace for the past 4 hours. We're seeing a slight ramping down of a high-speed coronal hole stream. Although things pretty stable here, pretty steady as far as solar wind for the past 24 hours. By the way, if you didn't see yesterday's stream, we did a live YouTube exclusive stream yesterday. Go check that out if you haven't seen it. Here's the last 4 hours of Earth's magnetic moment from the ground. We've moved to a little more calm type geomagnetic conditions here at the moment. And here's your KP index. We like the higher resolution KP index here where it's decimalized. That's good times. Current conditions are only a KP2 at the moment. Geomagnetically calm conditions. So here's the real-time solar wind. We did have a little increase there in the solar wind velocity for a brief period of time. Made it up to 621 kilometers per second. Things at the moment much slower here. 527 kilometers per second for the solar wind speed. Solar wind density 11.6 protons per cubic centimeter. The fields are looking pretty weak there, only 5 nanotesla with a BZ of positive 2. Make it 4 nanotesla with a BZ of positive 2. Geomagnetic calm conditions. Next to GOES magnetometers. There you go. There they goes. There are the GOES. As they measure the magnetism around Earth from their geosynchronous near equatorial orbits. Let's take a look at the top view ecliptic plane field plot. We see some evidence that the north solar polar field here is finally perhaps leaving the north heliographic polar region. See it shrink down a little bit there. Taking its good old time as the south solar polar field left the south heliographic pole long ago. Earth remains in a south pole current sheet depicted here in red. Next, our line of sight field plot. There you have the sun's field in blue, the B field that is. That's the field that goes through the magnet if this magnet is the sun. South solar polar field in red, north solar polar field in green. And let's move to coronal holes. We've got some south pole coronal holes rotating in here. They're not very well defined. As you'll be able to see from the SDO 211 angstroms. There you go. Those are south pole oriented coronal holes there on both sides of the equator. We probably can't expect very much high-speed coronal hole wind streams from those. Those are pretty minor coronal holes indeed. Thanks for leaving a comment, Acrylic D. Next, moving to sunspots. And the likelihood of solar flares has gone up with the evolution of sunspot 3112. It has grown some umbra kind of in the middle of it. Besides that, things relatively calm here, and we're going to show you some fantastic imagery. Some close-up imagery of the closest star. First, take a moment to visit our links. If you haven't seen SmashoMash.com yet, in 2019, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security social media stockade to the internet underground, where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the freaking content, maybe you can hire the Smash team. In fact, I'm sure you can. I'll bet you're able to visit our website also at SmashoMash.com. All kinds of links available there, including a link to SureMed. You want to improve your health? Join the American Better Health Organization. It's a nonprofit dedicated to improving the health of its members. So pick up a SureMed membership. At the premier level, you get accident and critical illness insurance thrown in. Also things like doctors by phone, virtual veterinarians, dental discounts, counselors by phone. Make sure you use my link to make me your agent on record. Your agent of record should be me. So use my link to sign up for SureMed. We appreciate all of you who have. If you want to support the channel via subscription membership, become a member at the gold or silver level and become an executive producer of the content at smashamash.com/smashteam. This is our anniversary month. We just launched it last October. And thanks to everybody who's signed up. Thanks for leaving a comment, BMVR13. Thanks to our gold and silver Smash Team members. There's even a bronze membership level, which is of no cost. You'll get email alerts like everybody else for disasters. Today's featured product is Mensa, which stands for Make Earth Not Suck Again. And it's up to you. It's not a political slogan. It's not up to terrible decision-making of bureaucrats. It's up to you. So think global and act local. Mensa, Make Earth Not Suck Again. It's up to you, not giant bureaucracies that can't even get out of their own way. Jack be nimble, Jack be quick. Jack don't be such a dick and make Earth not suck again. Tell your friends and foes about it. I'm wearing the hat. See, right there. That is where it's at. Thanks to everybody who's picked up merch. That is our second bestseller. If you click the link below the video or on the homepage, you'll find our merch shop there from Redbubble in order of best selling. It does feature products that shall not be named because this video will eventually be loaded to YouTube. Are you still using Google as a verb? I'll just leave it at that. Make sure you smash the like button. Don't forget to mash the subscribe button if you're new to the channel. Thanks to everybody who's tolerated the pathetic censorship on the platform over the past pushing 6 years of the most detailed space weather video you'll find in the world. Check out our playlists for videos unrelated to Earth and space weather. You'll find things like music videos, the Diamond Anvil, Too Hard to Smash, and lots more. And let's get to sunspot imagery. So here's some fantastic composite imagery there from SDO, 193 plus 171 angstroms. There is an M-class flare in there. We'll get to that here momentarily. First, the magnetogram from SDO. That's the last 24 hours. And here is the SDO continuum. Again, a little bit of umbral growth there, kind of in the middle of sunspot 3112. That, I believe, increases the likelihood of large solar flares. Next, we'll move to solar flares. We did see one M-class event. It happened at 0 dark 40. 0 dark 40 is when that M-class flare occurred. It was an M1.09. I don't believe it sent any relativistic particles. We don't see any yet. The GOES proton flux is flatlined. Let's take a look at some flare wavelengths. 94 angstroms is always a good choice. We've also got 131 angstroms. How about a composite? There's both of them combined. And how about a close-up? And that M-class flare indeed coming from sunspot 3112. Or did it come from this sunspot? I'm not sure. Might have come from this sunspot. In any case, the likelihood of large flares remains very high. There are still a lot of sunspots on the earthly portion of the solar disk. If you're up before dawn, you may see Mercury rising ahead of the sun. If you've got clear skies and a low horizon, Mars is high in the sky near the galactic plane, which is the blue line there. And the moon is setting in the west over Lehigh Valley. Here's your solar system forecast. Here's where things are now. And there's where things will be in a week. As Mercury, Venus, and the Earth begin to head to the far side of the solar system. Next, some coronagraphs. And do we have earthly directed CMEs? Well, we do have one, which I'm fairly convinced is going to strike late in the day today or early in the day tomorrow. However, are these Earth directed? We'll get to it. That's today's imagery. Here's yesterday's imagery. Lots of pretty spectacular CMEs here. Again, that's yesterday. Let that play through one more time. And there's today. Let's clarify things by looking at the view from Stereo A. We do have data from Stereo A, so let's check it out. And basically, so I paused this here around 1953. There you go, 1953. You can see this filamentary feature up here, which also shows up on the SOHO-LASCO C3. Indeed, that is not earthly directed. Now, we are missing most of the data from today here. We're only getting to 323 there. But at the moment, we don't see any Earth-directed ejecta. Just some stuff on the far side and well off to the north. Again, we are expecting a CME strike late today and or early tomorrow. Between, I'll say, 2100 tonight Universal Time until about 12 noon tomorrow Universal Time. So here's the last 24. Lots of CMEs there. Great view of Venus as well. Let's move on here. We don't want the video to be too long. We've got lots of filaments on the earthly facing portion of the solar disk as well. See all these dark absorption features? Those are all solar filaments. So those are all plasma suspended out there in the corona. Likelihood of additional coronal mass ejections remains nearly 100%. Expect more CMEs. Some of them could be earthly directed. So here's the last about 2.5 hours from the GOES 16 SUVI. You can see actually a CME propagating right here from the northeast. Right there. Just the tail end of it. Tail end of it. Again, that's the last about 2.5 hours there. We'll be streaming it once again today on the Twitch channel at twitch.tv/SmashoMash. Here's the last 24 hours from the higher resolution SDO. And you can indeed see this filament up here releasing. There it goes. Part of it looks like it collapsed back down onto the sun. Part of it looks like it is now making its way out through the solar system. Not likely to be directed at the Earth either. It's on the far side of the sun. Next, moving into bonus features. We've got some charging hazards here of the internal variety over the Indian Ocean, moving into Africa and around Oceania, the West Pacific. Also some minor surface charging hazards there over Mexico and the East Pacific. Here is your GOES electron flux over the past 3 days. We have been seeing increased electron flux there. There's the 7-day graph of the electron flux as measured by the GOES 16 and GOES 17. NOAA forecasting a small increase and then a dip in the electron flux. No argument there. Here's the 1-year graph to put it in context. We'll show the F ionosphere layer, which is full of anomalies. Check it out. So the F layer is located at 300 kilometers of altitude. It's in many ways the bridge between space and Earth. This is the portion of the atmosphere that the GOES 16 and GOES 17 measure the electron flux, but they do it from well above there. So they're at like 10,000 miles of altitude. This is at about 300 kilometers of altitude. That is the vibrational frequency of the F ionosphere. And if you're not familiar with looking at that, it is full of anomalies. Here's the anomalygram showing anomaly in megahertz from a 30-day median. And you'll see both significant high and low frequency anomalies happening here. Let's bring up the latest image. There's 10:15 universal time ionogram and 10:30 universal time anomalygram. Let's show the total electron content as well. It's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. We do see some electrons out of place here. We see high levels of electron flux at nighttime on various portions of the planet. Those red areas are the most likely places to see GPS errors. We see extended levels of high electron flux happening there over places like the East Pacific. That is literally the count of electrons. That's 10 to the 16th power electrons per meter squared. So it's like a 2D representation of the total electron content in the entire vertical air column from about 12,500 miles of altitude all the way down to your ground-based GPS handset. Some minor polar anomalies happening there around Antarctica. Continuing on, here's the latest intensitygram and latest colorized magnetogram. And there is sunspot 3112 and 3116. They are just spectacular. There is some beta gamma delta class action happening there. Again, likelihood of major flares quite high. Let's also look at this group as it has produced some flaring as well. That's at least beta gamma class. Not really delta, just beta gamma class. But I believe it has produced some significant flares. In fact, I think it might have even been responsible for that M class flare. So anyway, these minor plages over here, those are not sunspots. And let's move on to one more series of images here from SDO. This is Iron Star. 335, 193, and 94 angstroms from SDO. That is yesterday plus today. And it's time to transition from space weather to Earth weather. In the meantime, let's pause for station identification. Thanks for tuning in to the Smash News Network, least busted name in news. Now we're looking at Saharan dust. And there's lots of Saharan dust there in the central Atlantic. That'll be tamping down on these systems that are trying to cause convection out here. That is pretty dusty right there. Pretty dusty indeed. If you want to look at it yourself, that is the DUEX, by the way. Click on particulates, click on DUEX. That is the 550 nanometer optical thickness aerosol content. And here are the winds on the surface level around Oceania and the Far East. Here are the jet streams of the eastern world. A little bit of backward jet stream action there over the northern Indian Ocean. Strong jet stream over most of Australia. Here are the jet streams of the western world. We've got a convergence of the jet stream over the eastern U.S. Triple jet streams becoming one there as they head over to Europe. Here are the surface winds. Surface winds of the central world. And lastly, the jet streams. Here's 3.9 nanometer infrared radiation over the western world. That'll show clouds and fog when it's too dark to use the visible satellite. It's the NASA GOES Interactive Weather Satellite Suite. As Central America gets pounded with some heavy rains. We've got some frost advisories once again in places like West Virginia, Kentucky, Tennessee, Virginia, and southern Ohio. Also parts of Maryland, Maine, and New Hampshire. Also parts of Colorado, and some flooding expected there in southwestern Texas. If your county's lit, click your county on weather.gov. And let's bring up some forecasts. First, we're going to show total accumulated precipitation. This is based on the GFS model. Give that a minute to initialize. Since we're getting some flooding expectations there in Texas, that is the 72-hour GFS total accumulated precipitation forecast. It is showing precipitation totals in inches. Some parts of Texas there expecting about 3 inches of rain. Also some heavy rains coming to the southern Great Lakes states. We're also going to show the temperature forecast. These data were not available when we did show prep. That's why we're bringing them up now. This is your 72-hour GFS temperature forecast. It is in degrees Fahrenheit. Some temperatures making it into the 20s there in places like Wyoming and Colorado. And making it into the 30s in large portions of the eastern part of the U.S. there. And let's continue on as we don't want the video to be too long. I think we're going to windy.com next. There's our satellite imagery from windy.com. By the way, they've got a great mobile app. If you've never seen it, windy.com. Download the mobile app. It's free. As the sun rises over the eastern seaboard. That's what's going on. A little bit stormy over Central America. Next, our NASA GOES Lightning Mapper. Some strong lightning there in southwestern Texas, indeed. Let's check and see if we've got any terrestrial strikes. Looks like we may. Indeed we do. McCamey, Texas. There's thunder rolling in. Also at Iran. It's east of Fort Stockton, south of Odessa. We'll see if we can get a beat on how those systems are moving here in a moment. Next time you hear thunder, check it out, lightningmaps.org. And here's your U.S. Doppler radar. We're focusing on the lower 48 for the remainder. And those systems in southwestern Texas look like they're moving to the northeast. Here is your clouds and fog view. Again, 3.9 nanometer radiation. It's the infrared spectra. And last but not least, water vapor. And there is a bit of a push from some dry mass of air from the southwest. Here's your recap, and thanks for tuning in to the Daily Space Weather. We throw in the meteorology because it's just too easy to forecast the Earth weather. There is your shortwave radiation showing clouds and fog. And there is your water vapor map. Thanks for tuning in once again, folks. Congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-A-Mash, signing off. And may that solar wind be at your back.